Okay, today we're going to discuss the initial condition and initial value problem. So we define initial condition or conditions. They are a condition or a set of conditions on the solution that will allow us to determine which solution that we are after. So usually the initial conditions are of the form. We have y of t sub o is equal to y sub o and or y raised to k of t sub o is equal to y sub k. Now, let's put that one into example. So, y of x equals x to the power of negative 3 halves is a solution to 4x squared y double prime plus 12xy prime plus 3y is equal to 0. And the initial value condition, we have y of 4 is equal to 1 over 8 and y prime of 4 is equal to negative 3 over 64. So to solve for this, we need to satisfy the two conditions. First, the given equation of y of x equals x to the power of negative 3 halves, we have to show that this one is a solution to the given differential equation. That's the first one. Next, we have to satisfy as well that the given equation will satisfy to the initial value condition. All right. So in order for us to conclude that it is a solution, then we must satisfy the two conditions. Okay. So not only one, but it should be two conditions. So since we have the order of the differential equation is a second order, then we need to take until the second derivative. So we have the first derivative now will be y prime of x is equal to the negative of 3 halves of x to the power of negative 3 halves minus 1. So that is now negative 5 over 2. And after that, we take the second derivative. So we have negative 3 halves times negative 5 over 2. So we have positive 15 over 4 of x to the power of negative 5 over 2 minus 1. Then it becomes now negative 7 over 2. So after that, we are going to substitute these values of y double prime, y prime, and y to the given differential equation. So by substituting to that, we have now 4x squared of y double prime plus 12xy prime plus 3y is equal to 0. Now, with a substitute, 4x squared times the second derivative now is equal to 15 over 4 of x to the power of negative 7 over 2 plus 12 times x times the value of y prime or the derivative of first derivative or the value of y prime is equal to negative 3 halves of x to the power of negative 5 over 2 plus 3 times the value of y. The meaning of y now is coming from the given equation. So that is now 3 times x to the power of negative 3 over 2. So is equal to 0. Now we are going to work on the left hand side that the result should be equal to 0, or else if the result on the left hand side is not equal to 0, then we could say that y of x is equal to x to the power of negative 3 half is not a solution to the differential equation. Now let's try to simplify it now. So by simplifying, 4x squared times 15 over 4 of x to the power of negative 7 over 2. So 4 will be cancelled. So we have 15 times x squared times x to the power of negative 2. So the new exponent now will become x to the power of negative 3 halves plus 12 divided by 2 is 6 times negative 3. So this must be now negative 18. Negative 18 of x to the power of, so add the exponents of 1 minus 5 over 2. So the new exponent there is negative 3 over 2, and multiply the last term. So we have now 3x to the power of negative over 3 over 2. This will be equal to 0. Okay, then since they are like terms, so we can combine, and the result for this become 15x to the power of negative 3 over 2 plus 3x to the power of negative 3 over 2 is equal to 18x to the power of negative 3 over 2 minus 18x to the power of negative 3 over 2 is equal to 0. So since this the 18x to the power of negative 3 over 2 minus 18x to the power of negative 3 over 2, so the left hand side now will give us 0 is equal to 0, which is now true. So therefore, the given equation of y of x equals x to the power of negative 3 over 2 is a solution to the given differential equation. So now we have satisfied the first condition. So next is we are going to satisfy the using the initial value condition. Now for that, we are going to solve when x is equal to, so when x is equal to 4, then we have to solve for y of x is equal to x to the power of negative 3 over 2. So when x is 4, so you can write now y of 4 is equal to, our x now is equal to 4. So 4 to the power of negative 3 halves. So to solve for that, or to simplify for that, you take first the square root of 4. So the square root of 4 is 2, then raised to the power of negative 3. Then 2 to the power of negative 3 can be written as 1 over 2 to the power of 3. And we know that the denominator will give us the value of 8. So therefore, y raised to 4 is equal to 1 over 8, which means we satisfy the first condition. Okay, we have y of 4 is equal to 1 over 8. Now, on the second condition from the initial value, so we have, so when x is equal to 4, then y prime of x will be is equal to negative 3 over 2 of x to the power of negative 5 over 2. So I will replace x by 4. We have now y prime of 4 is equal to negative 3 over 2. Replace x now by 4, then raise the power of negative 5 over 2. So in the same manner what I did on the first initial value, so we have to take the square root of 4 is equal to 2. So I will write first the coefficient of negative 3 over 2 times the square root of 4 is 2, and then raise to the power of negative 5. Now this will be, if you are going to simplify that one, it will give you the answer of negative 3 over 64. So since we have satisfied the differential equation as well as the initial value conditions, now we could say that the equation of y of x is equal to x to the power of negative 3 over 2 is a solution to the given function. Okay, so initial value problem. An initial value problem, or IVP, is a differential equation along with an appropriate number of initial conditions. So let us try to analyze, determine whether any of the following functions. For letter A, we have y sub 1 equals sine 2x. Letter B, y sub 2 of x is equal to x. Or C is y sub 3 of x is equal to 1 half of sine 2x is a solution to the initial value problem of y double prime plus 4y is equal to 0, y sub 0 is equal to 0, and y prime of 0 is equal to 1. So correction for letter A, this must be y sub 1 of x. So this is now, so letter A here, we are going to write y sub 1 of x is equal to sine 2x. So let us take the derivative until the second derivative. So we have here the y sub 1 prime of x is equal to the derivative of sine 2x is equal to cosine 2x. Derivative of 2x is 2, therefore we have 2 cosine 2x. Okay, and the second derivative for this, we have y double prime of x is equal to derivative of cosine is negative sine. So therefore 2 times negative 2 becomes now negative 4 sine 2x. Okay, so we have now up to second derivative. So by substitution to the differential equation, so we have now y double prime plus 4y is equal to 0. So write the meaning of y double prime, which is now negative 4 sine 2x plus 4 times the value of y, which is the original given, which is now sine 2x, is equal to 0. So we have negative 4 sine 2x plus 4 sine 2x. So is equal to 0. Since they are the same terms with the opposite sign, or they are additive inverse, so we could say that the left hand side is equal to 0, and that is also equal to the right hand side. So that is now true. So therefore, we could say that the given equation of y equals sine 2x is a solution to the given differential equation. So we have satisfied the first condition, and then using the differential equation. Now we are going to use the initial value condition, wherein y of 0 is equal to 0 and y prime of 0 is equal to 1. So when x is equal to 0, therefore y sub 0 is equal to sine 2x. Replace x by 0. So therefore sine of 2, we have 2 times 0 is equal to sine 0. Then the value of sine 0 is equal to 0. That's why, so sine of 0 is equal to 0. Therefore, we have satisfied the first initial value condition. So we have satisfied the first value condition. We have y sub 0 is equal to 0. Now, for the using the other condition, we have y prime. We have y prime of 0 is equal to 2 cosine 2x. So replace x by 0. We have 2 times cosine of 2 times 0. So 2 times 0 is 0. Then 2 cosine 0. But cosine of 0 is equal to 1. That's why we have 2 times 1 is equal to 2. So we have now y prime of 0 is equal to 2. So from y prime of 0 is equal to 2, we could say that that condition does not satisfy. Therefore, it is not a solution to the initial value problem. Okay, because in order for us to satisfy the initial value problem, then it must satisfy the two conditions. What are the two conditions here? We have y sub 0 is equal to 0 and y prime of 0 is equal to 1. It happens that only y sub 0 is equal to 0, which satisfied to our condition, and the second condition, they are not equal, because our result here is y prime of 0 is equal to 2. So therefore, it does not satisfy to the initial value problem. So next example is that find a solution to the initial value problem y double prime plus 4y is equal to 0, y sub 0 is equal to 0, y prime of 0 is equal to 1 if the general solution to the differential equation is known to be y of x equals c sub 1 of sine 2x plus c sub 2 times cosine 2x. So we have y of x is equal to c sub 1 of sine 2x plus c sub 2 of cosine 2x. So the derivative of that will be y prime of x is equal to 2 c sub 1 of cosine 2x minus because the derivative of cosine is negative sign. So we have now negative 2 sine of 2x. Now taking the second derivative, so we have derivative of cosine is negative sign, so therefore negative 2 times the derivative of 2x is 2, so therefore negative 4 c sub 1 of sine 2x minus the derivative of 2 sine 2x equals 4 cosine of 2x. Now let us substitute that to the equation of y double prime plus 4y is equal to 0. So y double prime means negative 4 c sub 1 of sine 2x. We have minus 4 cosine of 2x plus the second term is 4y. So 4 times the value of y is we have c sub 1 of sine 2x plus c sub 2 of cosine 2x is equal to 0. So if we are going to use the derivative property on the second term, which is 4 times y, which this is the value of y. So this will be now for negative 4 c sub 1 of sine 2x minus 4 cosine of 2x plus 4 c sub 1 of sine 2x plus 4 c sub 2 of cosine 2x is equal to 0. So by inspection, we can write negative 4 c sub 1 of sine 2x. So this one and this one are additive inverse. While the other terms, we have negative 4 cosine 2x and we have 4, it should be, there's a lacking here. It must be 4 c sub 2, 4 c sub 2 of 4c sub 2 cosine 2x, and we also have positive 4c sub 2 of cosine 2x, so they are also additive inverse. So everything now on the left hand side is equal to 0, and that is equal to 0 on the right hand side. So since this is a true statement, we could say that the given equation of y of x is equal to c sub 1 sine 2x plus c sub 2 of cosine 2x is a solution to the given differential equation. Now we have satisfied the differential equation. Now this time we're going to satisfy as well the initial value problem. So to do that, we have uh, y sub 0 is equal to using the y of x. So we have now c sub 1 of sine 2x plus c sub 2 of cosine 2x. I will replace x by 0. So c sub 1 of sine 2 times 0 is 0 plus c sub 2 of cosine 2 times 0 is cosine 0. Then taking the value of sine 0, so we know that sine 0 is equal to 0. We have c sub 1 times 0 plus c sub 2. We know that the value of cosine 0 is equal to 1. Therefore, c sub 1 times 0 is 0, so we will just not write anymore. We just cancel. So therefore, we have y sub 0 is equal to c sub 2. So we have this value that y sub 0 is equal to c sub 2. Now, we need to solve for c sub 1. So to solve for c sub 1, we're going to use the other condition. We have y prime of 0 is equal to, so the first derivative is we have 2c sub 1 of cosine 2x minus 2c sub 2 of sine 2x. So let us check if that is correct. So y prime of x is 2c sub 1 of cosine 2x minus 2 sine 2x. So that is what I am writing here. All right, then after that, so knowing that the value of c sub 2 is equal to 0. So we can substitute it here. Then we can solve for c sub 1. So we have y prime of 0 is equal to 2c sub 1 of cosine 2x minus 2 times the value of c sub 2 is, as the value of c sub 2 is 0, and then sine of 2x. Okay, we just write for sine 2x. So we can write now 2c sub 1 of cosine 2x minus 2 times 0 is 0. So 0 times sine 2x is another. So the answer is also 0. Now, so we can just write now that y sub o, y prime of 0 is equal to 2c sub 1 of cosine 2x. So we want to solve for c sub 1. So to solve for that, I will replace x now by 0. So therefore, 2c sub 1 of cosine 2 times 0 is 0. Then, taking the value of cosine 0, we know that cosine 0 is equal to 1. Therefore, we have 2c sub 1 times 1. Or we could say that y prime of 0 is equal to 2c sub 1. From this value that y prime of 0 is equal to 1, now I can write, so from the initial value condition of y prime of 0 is equal to 1, so therefore I could write this one now, 1 is equal to 2c sub 1, and solving for c sub 1, we have c sub 1 now is equal to 1 half. So we have now c sub 1 equals 1 half and c sub 2 is equal to 0. So by substituting now to the given equation of y of x is equal to c sub 1 of sine 2x plus c sub 2 of cosine 2x. So replace the value of c sub 1 and c sub 2. So c sub 1 is 1 half of sine 2x plus the value of c sub 2 is 0. So 0 times cosine of 2x. So that is now equal to 0. So therefore, y of x is equal to 1 half of sine 2x. So this one now as the, so y of x is equal to 1 half of sine 2x is the solution of the initial value problem. So we could say, we can conclude that this one, say, therefore, y of x is equal to 1 half of sine 2x is the solution of the initial value problem. Okay. Okay, find a solution to the boundary value problem of y double prime plus 4y equals 0, y of pi over 8 equals 0, y pi over 6 equals 1, if the general solution to the differential equation is y of x equals c sub 1 of sine 2x plus c sub 2 cosine 2x. So first we are going to to note that y is equal to pi over 8. So we are going to substitute this to the equation of y of x equals c sub 1 sine 2x plus c sub 2 of cosine 2x by replacing x as pi over 8. Now we have c sub 1 times sine of 2 times pi over 8 plus c sub 2 of cosine of 2 times pi over 8. So simplify that one. We have c sub 1 sine of 2 pi over 8 is equal to pi over 4 plus c sub 2 of cosine pi over 4. Now after that, we are going to take the value of pi of sine of pi over 4 as well as cosine of pi over 4. So we have now y of
pi over 8 is equal to c sub 1 of, okay, the value of sine pi over 4 is equal to the square root of 2 over 2 plus c sub 2. Then the value of cosine pi over 4 is also square root of 2 over 2. So from of pi over 8 equals c sub 1 of square root of 2 over 2 plus c sub 2 of square root of 2 over 2, we need to satisfy the condition of y of pi over 8 is equal to 0. So when y of pi over 8 is equal to 0, so we have 0 is equal to square root of 2 over 2 of c sub 1 plus square root of 2 over 2 of c sub 2. So solving for this, so this can be now our equation number 1. I will call this one as equation number 1. Now, we're using the other value of y of pi over 6. So we are going to substitute this to the equation of y of x. We have c sub 1 of sine of 2x plus c sub 2 of cosine 2x. So we have to write c sub 1 and sine of 2 times pi over 6 plus c sub 2 of cosine 2 times pi over 6. So simplifying that one, we have c sub 1 of sine of pi over 3 plus c sub 2 of cosine of pi over 3. Now taking the value of sine pi over 3 as well as cosine of pi over 3, so this will give us the value of c sub 2 of square root of 3 over 2 plus c sub 2 of cosine pi over 3 is 1 half times 1 half, and this will give us now, since pi y of pi over 6 equals 1, so I will write it immediately here as 1 equals, simplifying this one, we have square root of 3 over 2 of c sub 1 plus 1 half of c sub 2. I will name this one as equation number 2. Okay, from the equation 1 and 2, we have, I write it again, we have square root of 2 over 2 of c sub 1 plus square root of 2 over 2 of c sub 2 is equal to 0. And the second equation, we have square root of 3 over 2 of c sub 1 plus 1 half of c sub 2 is equal to 1. So in this case, I will be going to use a substitution method to solve for the other equation. So shall we say we have square root of 2 over 2 of c sub 1 plus square root of 2 over 2 of c sub 2 is equal to 0. So if I'm going to transpose the other term, so we have now square root of 2 over 2 of c sub 1 is equal to the negative square root of 2 over 2 of c sub 2. Then, to eliminate their coefficients, I'm going to multiply the entire equation by the reciprocal of this coefficient. Since their coefficients are the same, which is square root of 2 over 2, and the other one is also square root of 2 over 2. So to eliminate the coefficient, so I'm going to multiply by its reciprocal, which is now 2 over square root of 2. Now multiplying that one, 2 over square root of 2 times square root of 2 over 2 of c sub 1. So this will give the product of c sub 1 is equal to the negative of c sub 2. Now from there, I'm going to use the other equation, the second one. We have square root of 3 over 2 of c sub 1 plus 1 half of c sub 2 is equal to 1. Now to eliminate the denominator, I'm going to multiply the entire equation by 2. Now, therefore, we can have 2 times square root of 3 over 2 of c sub 1. So 2 there is will be cancelled. So we can have now square root of 3 of c sub 1 plus 2 times 1 half of c sub 2 is equal to c sub 2 is equal to 2 times 1 equals 2. Now from there, I'm going to solve for c sub 2. So by transposing, we can write now c sub 2 is equal to 2 minus the square root of 3 of c sub 1. Now, since we have solved earlier that c sub 1 is equal to negative c sub 2, then I'm going to substitute the meaning of the value of c sub 2. So we have c sub 1 is equal to the negative of 2 minus square root of 3 of c sub 1. And then simplifying on the right hand side, we have c sub 1 is equal to negative 2, negative times negative square root of 3 is positive square root of 3 of c sub 1. Okay, by combining like terms, because we have c sub 1 on the left side and the right side, we also have c sub 1. So combining the terms, so we have to transpose negative 2, then this becomes 2 is equal to square root of 3 of c sub 1 minus c sub 1. Then factor out the common factor of c sub 1. So we have 2 is equal to, we have the factor is c sub 1 times square root of 3 minus 1. Now, we can solve for c sub 1 by dividing both sides by square root of 3 minus 1. So, we have now c sub 1 is equal to 2 over the square root of 3 minus 1. So, we have now the value of c sub 1, which is 2 over the square root of 3 minus 1. Okay, now we know that c sub 1 is equal to the negative c sub 2. Therefore, we could say that using this condition that we solved earlier, c sub 1 is equal to negative c sub 2. Therefore, from this idea that c sub 1 equals negative c sub 2, and we know that c sub 1 now is equal to c sub 1 is equal to 2 over square root of 3 minus 1. Therefore, the negative of c sub 2, then the negative of c sub 2 is equal to the negative of 2 over the square root of 3 minus 1. We could say that c sub 1, okay, we could say now that c sub 1 is equal to negative c sub 2 is equal to the 2 over square root of 3 minus 1. So after that, we are going to substitute these values into y of x. So we can now have, I will write here the y of x. So therefore, we have y of x is equal to c sub 1 of sine of 2x plus c sub 2 of cosine 2x. So by substitution, we can write now y of x is equal to, the value of c sub 1 is 2 over square root of 3 minus 1 of sine 2x, then plus c sub 2 of cosine 2x. We know that c sub 2 now is the negative of 2 over, so therefore positive times negative here becomes now negative 2 over square root of 3 minus 1 of cosine 2x. Or you can factor out the, since there's a common factor of 2 over square root of 3 minus 1, so we can write, so we can write as y of x is equal to 2 over square root of 3 minus 1 times the quantity of sine 2x minus cosine 2x. So just let me write here, since I don't have space, so therefore the final answer now will give us, we have y of x is equal to 2 over square root of 3 minus 1 times sine 2x minus cosine 2x. So this is now the answer to our question, that is finding the solution to the boundary value problem of y double prime plus 4y is equal to 0 given the initial value conditions. Determine c sub 1 and c sub 2 so that y of x equals c sub 1 sine 2x plus c sub 2 cosine 2x plus 1 will satisfy the condition y of pi over 8 equals 0 and y prime of pi over 8 equals square root of 2. So first I'm going to take the derivative since there is a condition of y prime. So we have now, okay, when y of x is equal to c sub 1 of sine 2x plus c sub 2 of cosine 2x. So the first derivative for this, we have derivative of sine 2x equals 2c sub 1 of cosine 2x plus we have the derivative of cosine 2x is negative 2c sub 2 of sine 2x. Now, to satisfy the condition, we will use now y of pi over 8 is equal to 0. So, from the original equation of uh, y of x is equal to c sub 1 of sine 2x plus c sub 2 of cosine 2x plus 1, I will replace the value of x as pi over 8. So, y of pi over 8 is equal to c sub 1 of sine of 2 times x. We have 2 times pi over 8. So this becomes now pi over 4 plus c sub 2 of cosine 2 times pi over 8 is also pi over 4 plus 1. Now, I will take the value of sine pi over 4 as well as cosine pi over 4, and I will also write the value of y pi over 8, which is now equal to 0. So I can write now 0 is equal to sine pi over 4 is square root of 2 over 2 times c sub 1 plus cosine pi over 4 is square root of 2 over 2 times c sub 2. We have square root of 2 over 2 plus 1. So transpose 1. So we have now negative 1 is equal to square root of 2 over 2 of c sub 1 plus square root of 2 over 2 of c sub 2. Now, to eliminate the denominator of 2, so I multiply the entire equation by 2. So therefore, we have now uh, 2 times negative 1 is negative 2. So 2 times square root of 2 over 2 of c sub 1. So we have square root of 2 c sub 1 plus square root of 2 of c sub 2. Now, since there is a common coefficient of the constant of square root of 2, so I will factor out the common factor. We have negative 2 is equal to the square root of 2 times c sub 1 plus c sub 2. So after that, I will eliminate square root of 2. So I divide both sides by square root of 2. So we have now negative 2 over square root of 2 is equal to c sub 1 plus c sub 2. To simplify this further, I'm going to rationalize the left hand side. So rationalizing this one, negative 2 over square root of 2 times square root of 2 over square root of 2 is equal to c sub 1 plus c sub 2. So we have now c sub 1 plus c sub 2 equals negative 2 square root of 2 over square root of 2 times square root of 2 is 2. Then simplify that one, it gives us now the answer of negative square root of 2. So c sub 1 plus c sub 2 now is square root of negative 2. So this will serve now as my equation number 1. Now to solve for the second equation, we have, I will use the other slide. So we have using the y prime of x is equal to, we have 2c sub 1 of cosine 2x, 2c sub 1 of cosine 2x minus 2c sub 2 of sine 2x. Okay, they are correct. So now I'm going to use the condition of y prime of pi over 8, which is equal to the square root of 2. So square root of 2. So replace x now in this equation by pi over 8. So we have now square root of 2 is equal to 2c sub 1 of cosine 2x means 2 times pi over 8, which is now pi over 4 minus 2 times c sub 2 of sine of 2 times x. Again, we have 2 times pi over 8 is pi over 4. Now take the value of cosine pi over 4 and sine of pi over 4. So we have square root of 2 is equal to 2 c sub 1 of square root of 2 over 2 minus 2 times c sub 2 of square root of 2 over 2. Simplifying on the right hand side, we have now square root of 2 of c sub 1 minus square root of 2 c sub 2. So simplifying further on the right hand side, so I have a common factor of the square root of 2 times c sub 1 minus c sub 2. So dividing both sides by square root of 2, therefore I can write now c sub 1 minus c sub 2 is equal to 1. And this will be my equation number 2. So combining the first equation and the second equation, so we have equation 1, we have c sub 1 plus c sub 2 equals negative square root of 2. Okay, that's correct. And we have the second equation now, we have c sub 1 minus c sub 2 is equal to 1. So by inspection, we can easily cancel the c sub 2. Therefore, I will use elimination method by adding the two equations. So therefore, we have 2 c sub 1 is equal to 1 minus square root of 2. Then solving for c sub 1, we have 1 minus square root of 2 over all over 2. Now, that is our value for c sub 1. Now to solve for c sub 2, we can use any of the two equations, but for now, I will choose the second equation. Now solving for c sub 2, I will use c sub 1 minus c sub 2 is equal to 1. So I will manipulate it first before I am going to substitute. So we have now c sub 1 minus 1 is equal to c sub 2. Or we have c sub 2 is equal to c sub 1 is 1 minus square root of 2 all over 2 minus 1. So simplifying the two terms we have here, the LCD is 2. So 2 divided by 2 is 1 times the numerator, we have 1 minus square root of 2 minus 2 times negative 1 is negative 2. So simplifying again, so 1 minus 2 equals negative 1 minus square root of 2 over 2, or this is equal to taking the common factor of negative 1. So we have the negative of 1 plus square root of 2 all over 2. So these are now the two values of c sub 1 and c sub 2. So this is for the value of c sub 2, which is negative of 1 plus square root of 2 over 2, or just simply write this one as the negative 1 minus square root of 2. So we have satisfied now the question that we are asked to determine the value of c sub 1 and c sub 2, so that y of x is equal to c sub 1 of sine 2x plus c sub 2 of cosine 2x plus 1 will satisfy the given conditions.